In this video, we'll be talking about the other type of extrema, and that is local extrema. So that includes local maximums and local minimums. We'll also be talking about critical points, which are points where those local extrema possibly occur. Let's start by looking at the definition for a local maximum and a local minimum. I'm not going to take the time to read this formal definition to you, but you can see that it's very similar to the formal definition for an absolute maximum and an absolute minimum. What I want to do is I want to spend this time looking at the difference between an absolute extremum and a local extremum. And so I'm going to label some points here. This point right here is going to be A. This point right here is going to be B. This point right here is going to be C. And this point right here is going to be D. And then this point right here is going to be E. So I'm going to talk about each of those points. First off, I want you to notice that we do not have an absolute maximum on this graph. Why is it that we have no absolute maximum? Well, notice that we have these arrows showing that the graph continues upward on both sides. So as x approaches negative infinity, the graph is going to shoot off to positive infinity. And as x approaches positive infinity, f of x is also going to go to positive infinity. So there's no absolute maximum. We do have an absolute minimum. See if you can locate that. The absolute minimum occurs at A. Okay, so absolute minimum occurs at x equals A and has a value of f of A. All right, so that's an absolute minimum. You can see that it's the lowest point on the graph, isn't it? So this value right here is f of A. So let's look at the other points that I identified on the graph. At B, and the corresponding y value of f of B, we have a high point, don't we? Now, it is not an absolute maximum because we've already said that this graph does not have an absolute maximum. However, in its own little neighborhood, it is a maximum, so we call it a local maximum. There's another local maximum over here. It occurs at D, and the local maximum is f of D, isn't it? We also have some local minimums, all right? So we have a local minimum. See if you can identify those. One is at C, and one is at E, isn't it? Those are our local minimums. We can also, even though we identified this point right here, f of A as a global minimum, we can also call it a local minimum because in its own area, it's also a minimum, isn't it? So if a function has an absolute minimum or an absolute maximum at a point, it's also considered a local maximum or a local minimum, all right? The absolute extremum are also considered local extremum. If an absolute extremum happens at an endpoint, though, we do not consider that a local extremum. Instead, we consider that to be an endpoint extremum. I just wanted to familiarize you with that terminology. Now I want to take a moment to see if we can observe what happens to the tangent line when we have a local maximum or a local minimum. So in our first example, A, we see that it has a local maximum that occurs at C, right? And at C, we have a tangent line that looks like this. What is the slope of that tangent line? It's a horizontal line, and a horizontal line has a slope of 0. So that means that f prime of C equals 0, doesn't it? And it says it right here. In the second scenario, we have another local maximum at C. But in this case, our graph comes to a point, doesn't it? And if it comes to a point, we can't draw our tangent line horizontally. We actually have a tangent line that's vertical. All right. And if a tangent line is vertical, what kind of a slope does it have? It's undefined, isn't it? A vertical line has a slope that's undefined, so we can write f prime of C is undefined. Undefined. All right. Likewise, with C, we have a local minimum, but again, f prime of C is undefined in that case. Whenever the graph comes to a point, the slope is undefined. Now we have a name for those points C where the slope of the tangent line is 0 or the slope of the tangent line is undefined. And we call those critical points. Critical. So if we can find those points C where the derivative is 0 or where the derivative is undefined, we have identified our critical points. Now, as noted above, just because we have a critical point, it doesn't guarantee that we have a local max or a local min there. And I'm going to show you two images, D and E, where that is the case. So in image D, we have a derivative of 0 at C, so we have a horizontal tangent line at C, yet we do not have a max or a min there. All right, and the other scenario, we have a vertical tangent line, or f prime of C is undefined at C, and yet we do not have a max or a min there. So to summarize, we have these things called critical points, and they occur where f prime of C equals 0, or where f prime of C is undefined. But the critical points do not guarantee any local extremum. And we'll find out a way to test the function at those points to determine if you have a local maximum or a local minimum. But we'll do that at a later point.